Okay. Use the picture to the right to name each. So this is the picture. Classify triangle BEC by its side. So where's triangle BEC? This one, this triangle here, this one. By its side. So it's indicated here that this side is congruent to this side, right? So that means triangle BEC, the bases will also be congruent. So what kind of triangle is this? Okay, so you can answer isosceles. Then the next one, triangle AED by its angles. So this one, AED by its angles. So it's indicated here that this one is 125 degrees. Oh, okay. One of the angles is greater than 90 degrees, and the total measure of the angles inside the triangle is only 180. So 180 minus 125, it's 75, 65. So that means the total measure of the two remaining angles is 65 degrees. So we have one angle that is greater than 90 degrees. So what type of angle is this? Obtuse, acute, right, equilateral, isosceles, equiangular. So here the angles are not equal, so this is not an equiangular triangle, and the sides are not equal either, right? They have different sizes. The two angles are acute and one is obtuse. So this can be an obtuse. So triangle AED is an obtuse triangle. Then number 3, name a side opposite to angle C. So angle C here. Where is angle C? Side opposite to angle C, this one. Side from, yes, so that would be side BE. You can say segment BE. Okay. Then the next one. Find the measures of angle 1, 2, and angle 3 in the diagram below. 4 and 5. Okay. Number 6. Find the value of A. So this is a right triangle. This is 2A, this is A over 2. So we just add all of the angles. Yeah, the sum is 180 degrees, so that would be 90 degrees plus 2A plus A over 2 equals 180 degrees. Then we group like terms. 2A plus A over 2 equals 180 minus 90. So this is 90 degrees. 2A plus 1/2. 2 plus 1/2. What is 2 plus 1/2? 2A plus A over 2. This is just the same as, we can factor out A. 2 plus 1/2. Yeah, or 3 over 2. No, 5 over 2, right? Five over 2. I'm just trying to like write it in fraction form than in decimal. you add 2 and 1/2. A whole number and fraction, see. You get the LCD 2. 2 divided by 1, 2. 2 times 2 is 4. 4 plus 1. So that is 5/2. You got that? Okay. Then we divide both sides by... If you can use your calculator, then if you're allowed to use your calculator, then you can you're allowed. So you can use 2.5. 5/2. Because me, I don't want to use the calculator. So A here is just 90 times 2/5. So 90 is divisible by 5, right? So this is just 18. Then 18 times 2. I think we missed something. 36. So A is 36. That's the value of A. Then we go to number 7. Okay. Use the information below about the angles of a triangle to find the measure of each angle. Okay. Number 7. Okay. So can you go to another page and so I can upload number 8. Alright. Given the information below, find the value of x. So we're given triangle QRS is congruent to triangle GHJ. RS is equal to 12. QR is equal to 10. QS. Okay, let's draw the triangle then. Okay. Let's say this is triangle QRS. It says QR is 10. QS is 6, and then there's another triangle. This is GHJ. So HJ is 2x minus 4. Okay. RS is 12. QRS, GHJ. So that means RS corresponds to HJ. So we can equate them. Okay, let's equate them. So 12 corresponds to 2x minus 4. So we group like terms, so 12 plus 4, this is 2x. 16 equals 2x, divide both sides by 2, so x is equal to 8. Okay, you got that? For number 9, given the information below, fill in the congruency statement and postulate that justifies it. Okay, no such postulate exists. Write an A for both. Okay, 9. Triangle CDE is isosceles. G is the midpoint of CE. Okay, so that means this one, GD, is congruent to GD. Common side. And we're given that CD is already congruent to DE, right? And G is the midpoint of CE, so that means CG is congruent to GE, midpoint, definition of midpoint. So all the sides now are congruent. This one is congruent to this. This one is congruent to itself. Therefore, triangle, okay, DGC is congruent to triangle DGE. Side, side, side. Side, side, side congruence. Then for number 10, Okay. Oh, number 10. Okay, so because we're given the two angles, right? You were not the one who drew this. This is not given, or it's already given. Ah, okay. It says this one is parallel to this one. This one is parallel to this one. And this is right. Yeah. Because this one, they share a common side. And this one and this one, they're congruent, alternate interior angles, as well as this one, alternate interior angles. So we have triangle MLP is congruent to triangle MNP, this one. So the letter in between them, that should indicate the angle that are congruent. So that means angle N is also a right angle. So this one is angle, side, angle. Then number 11, CP bisects angle BCR. Okay, so this is BCR and angle BPR. They share a common side, so we have two triangles. This one, CP is congruent to CP, common side or reflexive property of congruence. PBC. So if it bisects, so that means what happened? Yes. Okay, so this one is congruent to this one and the other one is congruent to that one. Therefore, this angle is congruent to this. So triangle PBC is congruent to triangle PRC. So we have angle, then we have a common side, and then we have angle. Is this the ASA again? Okay, so that is ASA or AAS. Okay, number 12. Angle EAD, where is EAD? This one is congruent to EBC, this one, and then side AD, this side here is congruent to BC. Prove that triangle DAE is congruent to triangle, it should be triangle CBE. Okay, so what will be the postulate here? So we have congruent angles, we have congruent sides, the two sides, and then this one, this angle here, this one, and they share a common angle here, right? So angle, angle, okay, angle, angle, side. Let me compare. Compared to number 9 and number 11, number 10 and number 11, the side is included, right? That's why we answered ASA. So this one, the side is not included. It's angle, angle, and then side. So we can conclude that the side that they share, yeah, they don't share a side here, but it is indicated that this one is congruent to this one. CPCTC. Oh, what do you mean? Angle B and angle A? Oh no, it's already given. See? This one? Angle AED. Look, let me delete that. See, it's given here. Angle EAD, so it's indicated here. Like what I said, when you are representing an angle or a triangle, the letter between, or no, the middle letter that indicates the angle. So angle AED is congruent to angle EBC. It's already given. And they share a common angle. This one, angle E. Yeah, so AAS. Then number 13, JK, where's JK? This one is parallel to MN. So you can extend this one. Let's try to extend. That's the only given information. So if we're going to extend JKL, triangle JKL. Where's triangle JKL? JKL is congruent to, it should be congruent to NML. But we're only given one information here. AA. Corresponding angles. If we extend the transversal, there's no AA, right? So this one, they form vertical angles, so they are congruent. Yes. And this one, they are congruent, alternate interior angles if we extend this one transversal. And this one too, AA. But we're not given the sides are congruent. So we cannot prove this. Okay, number 14. Which one? Number 14? Okay, BA is congruent to DE. Okay, DA is congruent to BE. And they share a common side, this one. AE is congruent to, yeah. And so you're right, SSS. So triangle ABE is congruent to triangle EDA. This one. That one, can you see that? Okay, find the value of X and Y. It's given that AB is congruent to BC, then DE is congruent to EF. And X, okay, we can just plug in everything. AB is congruent to BC and we're given the values. So that is X squared equals 6X plus 16. And it says DE is congruent to EF. So we have two equations. X plus 2 equals 3Y. Yeah. So it's just like solving system of equations. Maybe we can rewrite this one as X equals 3Y minus 2. Then we can plug in the value of X here. So that would be X squared equals 6X plus 16. And then we plug in the value of Y, which is 3Y minus 2. Squared equals 6 times 3Y minus 2 plus 16. Then we FOIL this. This is 3Y minus 2. Do you know how to FOIL? This one is you distribute. This is 18y minus 12 plus 16. Okay. Let's FOIL this. 9y squared. This one minus 6y. And this one minus 6y. Then plus 4. 18y. And negative 12 plus 16 is 4. Then we group. Okay, 9y squared minus 12y plus 4 equals 18y plus 4. And we can put everything on one side, all of the terms, minus 12y plus 4 minus 18y minus 4 equals 0. So 4 cancels out, and we're left with 9y squared, 12 and 18, 30. 9y squared, and then we can factor out y, and this is y, and 9y minus 30 equals 0. So y can be 0, and the other one is 9y equals 30. So y, what am I? So it's 3.33. Okay. So we can now solve for x. So when y is equal to 0, we can solve for x here. X is equal to 3 times 0 minus 2. So x is equal to negative 2. When y is equal to 3.33, x is equal to 3 times 3.33 minus 2 times 3 minus 2 is 7.99, or approximately 8. So that's what I got, 8. Well, we just neglect y equals 0 and x equals negative 2. For number 15, do the following practice proofs on a separate sheet of paper. Okay, given DE. DE is parallel to JK. DK bisects JE. Okay, prove that triangle. Huh? 16. Nope, you don't have any problem with 15. Alright. Given angle FG, FGI is congruent to IGH. And it's already given that this one is a right angle, and GI is perpendicular to FH, so that means this is also a right angle. Yeah. Prove that angle F, this one, is congruent to angle H. So, okay. Do we do the table for this, like statement? Okay. Okay, we start with the given first. So angle FGI congruent to angle IGH. GI is perpendicular to FH. This is just given. Then, okay, what can we conclude from here if they are perpendicular? We can include right angles, right? GI is perpendicular to FH, so that means GIF and GIH are right angles. So angle GIH and angle GIF are right angles. Definition of perpendicular lines, or perpendicular lines form right angles. Perpendicular lines or perpendicular lines form right angles. No congruence. Okay, and they share a common side here. Alright, so we define the right angles, and right angles are equal to 90 degrees. So that means angle GIH is congruent to angle GIF and equal to 90 degrees. Definition of right angles. Oh, right angles are equivalent to 90 degrees. Then they share a common side, right? Common side, reflexive, bireflexive property. Yeah, they're congruent bireflexive property of congruence. Then we can prove that we already have two angles and common side. The side is included. So this is, we can conclude that triangle, triangle GFI is congruent to triangle GHI. Then a reason by ASA congruence. Yeah. No. Triangle FGI. Yeah. Am I right? GFI, GIF. No. G. So be triangle G. This one, IH is congruent to triangle GIF by ASA. But we need to prove that angle F is congruent to angle H. So when the rest of the parts of the triangles are congruent, so that means the other parts are also congruent. Right? Do you agree? So this is already congruent. And we're left with only one angle. Therefore, angle F is congruent to angle H. By what's that again? Congruent parts of congruent triangles are congruent. Yeah, CTC. Do you have questions? Okay, number 15. No, number 17. Okay, number 17. Given angle V is congruent to angle S, and then TV is congruent to prove that VR is congruent to SR. Okay, angle 1 and 2 are vertical angles, right? Okay. We can write here angle V is congruent to angle S, then side TV is congruent to side QS. These are given. Then what else are given? Those are the only ones given, right? Then angle 1 is congruent to angle 2, or they are vertical angles. And angle 1 and angle 2, they're vertical angles. Number 17. Yeah, they're vertical angles. It's number 17. Then we already have angles, and side. Yeah, because it's already given, this one. And then the sides also. And we can prove, we can use the triangle postulate, congruence. So number 3, that means triangle TRV is congruent to triangle SRQ. or maybe, okay, because we've already proven that they are vertical angles. Triangle TVR, that is given, is congruent to triangle QSR, right? Because we're only given the angles. This one, angle V and angle S are congruent. So that is this one, 2 angles and 1 side. And side is not included, so that is AAS, congruence. Then we prove that VR, this one, is congruent to that. So side VR is congruent to side RS or SR. I think this is still CPCTC because the 2 angles are already congruent, so that means this one is also congruent to the other one, and this side, the other side is also congruent. So congruent parts of congruent triangles are congruent. Okay, then number 18. Okay, given triangle XKF is equilateral. Equilateral meaning this one, this side is congruent to this and congruent to this. XJ bisects angle X. It bisects, so that means angle K, let me write that in. Okay, the first one, triangle XKF is equilateral. Then XJ bisects angle X. So this is given. Prove that J is the midpoint of KF. Okay. It says equilateral. So that means the sides are congruent. And then XJ bisects. So that means angle. It bisects, right? So that means angle KXJ is congruent to angle JXF or FXJ. Yeah. What will be a reason? By angle bisector? Yeah. So definition of angle bisector. Angle bisector. And then what are we going to prove next? They share a common side. Yeah, but it's also given that triangle XKF is equilateral, so all of the sides are congruent. So XJ, then XK, right? It's congruent to XF. This one is common side, reflexive property. Then the next one, what will be a reason for XF, XK, and XF? No, not yet, because it's given that it's equilateral. So you can just say equilateral. Version of equilateral triangles. Your exam is tomorrow for this. Yeah. This is also one of the exams that you missed. Okay. Since side XK is congruent to side XF, so that means the angles, the base angles are congruent. So angle 1 is congruent to angle 2. What will be our reason here? If 2 sides are congruent, then the base angles are also congruent. What will be that one? Okay, base angle. KJ. That is midpoint. But it's not given that it's midpoint. You have to prove that it's a midpoint. So you have to prove that KJ is congruent to JF or FJ. So from everything, right? It says XJ bisects there. It's not so perpendicular. So this one is congruent to this. This angle is congruent to this. They share a common side. This one. Okay. So that means triangle KJX is congruent to triangle FJX by XJ bisects. This angle is also congruent to KJ. What will be a reason here? The triangles, the two triangles are congruent. Because it's given that it bisects, right? XJ bisects. No, because it's not given that angle XJK is right and XJF is a right. And it's not given that they are right angles. So maybe we're given angle, this one is bisects, so that means this angle is congruent to this, and we have one included side, so that is by ASA. No, yeah. And then okay, so most of the, this one is congruent to this side, and this one is congruent to this side, and the angles are congruent, so that means the rest of the parts of the triangles are congruent. So that means side KJ or JK is congruent to side JF by CPCTC. Now, then the last one, that means J is the midpoint. Yeah, if this one, if JK is congruent to JF, then that means J is the midpoint of KF. Now the reason. What's the reason here? This is not the definition of midpoint. Is it the reverse? The other one? The reverse? The converse? Reverse. Converse. Let me check. We're not given here that J is the midpoint. We prove that midpoint. We need to prove that J is the midpoint. Okay, midpoint theorem. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side. Segment is half the length of the third side. Converse, if a segment from one side of a triangle is parallel to the third side, then it cuts the other two sides proportionally, and the point is a midpoint. But in this case, we've proven that side KJ is congruent to side JF by CPCTC. So I think that one is, counts for converse of midpoint. Yeah. But if you're given that J is the midpoint of what's this? JF, then you do it in reverse. You do like this. J is the midpoint of JF given. Then KJ is congruent to JF by midpoint theorem. Yeah. Are we good? You don't have questions on this?